Now, what would you really do to solve the equation? If this term was not there, and you said square root 2x plus 3 is equal to 2, what would you do now? Yes?
You can square both sides.
Square both sides.
Yes.
Square both sides and eliminate that square root. If it's just a single square root, eliminate that square root. I square both sides like he says. But on this one, for some reason, I get 2 square roots. Now I wish, I don't think it's going to happen, I wish this can be done. Put it in black here. This on both sides could be done when I have 2 square roots. I might think as a student professor, he just told you if there's only 1 square root, it's going to work out beautifully. Just square both sides. You eliminate that 1 square root. I've got 2 square roots. Some students may say, well, Professor, I can just go ahead and do it, because this just becomes this. Square the first one, you get 2x plus 3. And you got a subtraction sign here. And square the second one, I'll put it in parentheses, you get x plus 2. Isn't that cute? Dead wrong, but cute. Yeah, square both sides, you think, well, just square each one. You can't do it. Now, why? Because back in algebra somewhere, if you had this, which sort of looks like this is A, this is B, and you have to square that, that's not A squared minus B squared. That's not this and this. You guys told me earlier, more than likely it's this. It's A squared what? If you take A subtract B times A subtract B, or A subtract B squared, something like I'm doing here on this, what is A subtract B quantity squared going to give you? I'll tell you what it's not going to give you. It's not going to give you A squared plus B squared, or A squared minus B squared. Does anyone think they know what it's going to give you? Go ahead.
Is it A squared minus 2AB plus B squared?
2AB plus B squared. Have you actually set this down twice, which you could, and say, Professor, it's been a long time since I've had some math here, but I remember doing this. I could actually do it this way by doing that. That's what A subtract B squared means. And then use what you students call what, FOIL? Or expand this thing out, you'll get the same answer. I need to do that here. In other words, this is not it. If I square the left-hand side. Now, can someone be very, very, very careful? And you could reflect back to the middle school problem. And someone tell me what that would look like. Taking into consideration, this right here should give you this. If you apply this to my problem, can someone tell me what that left-hand side looks like?
2x plus 3.
Hang on up, 2x plus 3. Actually, it's in C. 2x plus 3.
2x plus 3 minus 2.
Hang on. Okay, 2x plus 3. Now I need this.
Yeah, minus 2
Thank you.
times the square root of 2x plus 3 times the square root of x plus 2.
Oh, that's exactly what we're doing here. Is that true?
And then plus,
Then plus?
x plus 2.
And you say when you square this right here, square root drops off and leaves you what? X plus 2. Strange if you do it like that. Is that true, guys? Is that expanded out? Is that strange looking? I applied this rule from middle school. Let's get across the street and do this. In fact, sometimes I walk across the street to see what they're doing there. I know some of those teachers over there. We may take a field trip one day. We walk over there and see what they're doing. It's shocking what they're doing in middle school these days. It's that, and he says, Professor, it looks like that. And then, of course, on the other side, you still have, what, 4? When you square the 2. That's true? Look how messy that looks. I'm trying to solve for x. That's all I'm trying to do. I'm trying to find out what x is, and some students get desperate. They say, Professor, can I just randomly choose numbers and replace x by maybe 5 and hope it works? Randomly let x be 0, Professor? Hope it works? We're hoping it's we'll get you there. So guys, that's true, but look how messy that is. yet I'm trying to solve the equation. What he gave me on the left-hand side is right here, he gave this to me perfectly based on this middle school. Perfectly. It's just messy. Now I'm going to erase. We'll erase this. I am not going to do this on this particular equation. Before I close down and maybe solve the equations here. I'm not going to do it. You saw how messy it's getting. And again, before I jump into what I am going to do, I wish this term were missing. If this term were missing, I could easily, as I heard earlier, just square both sides. Now that I can do easily. Anyone have an idea? I see a hand going up. Yes?
Keep the more complicated phrase on the left side.
Okay, you know what I can do? Keep this on the left-hand side?
Yeah.
Beautiful. And do what here?
And take the other one to the other side.
Thank you. Wait, Professor, move this over. Get it out of the way. Take this over. And he says, leave the square root 2x plus 3 all by itself. Now it needs to have just 1 all by itself. Which I one. Move the other one over. It looks a little strange though. It's going to look like this. We're going to move it over. Now watch carefully. Now can I square both sides? Yeah, the left-hand side's nice now. Right-hand side's not too nice, but at least the left-hand side's nice. If I jump in and say, well, that's a good suggestion now, Professor, do this. Do this. Left-hand side, no problem, Professor. It's gotta be 2x plus 3. Now, we still have the issue on the right-hand side. Can anyone tell me what this may look like expanded out with his help using this technique? Middle school says it should be this. I got this. Can anyone do what it may look like? A squared, what would A squared be if I extend this out? Is that 2 squared? 4? Now the next part says, mine's a plus rather than a minus, plus 2AB. What would that look like? 2AB, where A is here, B is here. What would I end up with for my next term? I see a hand going up, yes.
2x plus 4, so 2x plus 4.
Okay, tell me all together.
So it's gonna be, 4.
4
plus 8.
square root x plus 2. That would take care of that. There's a 2 there to begin with. 2 times A is 2, that's 4, 2 times 2. And B, of course, is that square root of x plus 2. The last part says, if I use the middle school, now square the B. Well, the B is that square root x plus 2. If I square it, I merely get what? X plus 2. Middle school, all is done. Now, do I have the answer at this point? No. Problem is, if I still have a square root, I gotta get rid of it. That means I must what do? I'm gonna use the word isolate. I must isolate that remaining square root and do this squaring again. Try to get rid of it. Guys, I'm gonna just leave this right where it is. The one that contains the square root, I'm gonna just leave myself. But I am going to move the others over, other terms. 4 is going to be moved over by subtracting, and all this business is going to be moved over. I just got to be careful how I move it. Guys, let me do this. X, oh, the 2 could be moved over. Don't make a mistake here. If I move the x over by subtracting, I got 2x already. If I move the x over right here by subtracting, I'll end up 2x subtract x is what? X. That's done. Mark those out. If I move the 4 over, 3 subtract 4 is what? Negative 1? And also I have to move what else over? Where am I? The negative 2, I move 2 over also. So I got a negative 1, 3 subtract 4 is negative 1. And then if I move the 2 over by subtracting, negative 1 subtract 2 altogether is what? Is that negative 3 altogether? Let's see if I move everything over correctly. And you still have this all by itself on the right hand side. You know about a problem. I'm waiting for this problem. Guys, make sure I move everything over correctly or we will really mess up on this. Does it look good? Okay, so this has been moved, this has all been put together, this has been done, this has been done. I'm left with that. Now, what do you think I'll do now? You gotta keep in mind, look at this mess, this is the original. This is the original, at least we got that here. Now, what do you think I'll do next in the attempt to go further and finally get a possibility for an answer? Yes, go ahead.
Square both sides.
Square both sides. Here we go. Bring some algebra in the first day I meet you here. If you square x subtract 3, that's x subtract 3 times x subtract 3, you're going to end up with x squared subtract 6x plus 9. That's again like this. This is just like this. On the other side, when I square, not too bad. Square the 4 out front, that's 16. If I square that last square root, which thank goodness it dropped off and leaves me x plus 2. Now I have no square roots to worry about. I eliminated all the square roots. Probably the toughest problem on your handout was this one. Now, not quite finished. We got x squared subtract 6x plus 9. Now the other side, guys, got a 16 out front like a distributive property. 16 times x plus 2. 16x plus how much? 32 is it? 16 times 2. Please tell me, after all this effort, even before I finished it, what on earth was this original equation? What was this original equation disguising as that we didn't know? It was disguising as a what? A quadratic. And I know how to deal with quadratics. I don't know how to deal with square roots unless I get rid of them. I can deal with the quadratic, so this thing's got to be a nice little quadratic. Now, let's see what I can do with this nice little quadratic. Let's put it in standard form. That means x squared is moving 16x over by subtracting 22x. Move that 32 over, and hope we do not make a mistake. 9 subtract 32, guys, help me out. What's 9 subtract 32? Maybe 23? Are you kidding? Who blocked this off? Are you kidding? You walk in Wednesday. You see this madness. You see this. You say, Professor, are you kidding? Why did you not give it to me in this form? Then you'd smile, Professor, and I'd smile, we'd all smile. No. I'm going to disguise for you. And you find out what it is. This thing came out to be a quadratic. Who would have thought? I hope the thing factors. I don't want to use quadratic formulas for those large numbers. I hope it factors. Guys, I hope it does. And let's see if it does. X and x for sure. Does anyone have a possibility for that, or the factors to make this work out? Yes.
Positive 1 minus 22.
Plus 1 and a minus 23.
23, yeah.
Beautiful. They factors. Now you're talking about factoring weak, Professor. Could I use quadratic formula? Go for it if you had large numbers. In that quadratic formula, it would work though, but you have large numbers here. Please give me the correct factors to set this up. Called zero product property. Set each one of these factors equal 0. And I'm going to end up with a consideration of -1 as an answer, 23 as an answer. What a beautiful problem. Now here's the sad part. Here's the sad part. If on the side here. Well, elementary school, not middle school, before I get back to this. If you solve this, you'd walk out of class saying, Range has lost it. 3 is equal to a -3, Range is no way. Unless you're trying to throw some grad school math on me I'm not aware of. I've never seen 3 equal to a -3. I have myself. That's false. then also you do this to it.